Yeah, sure. Okay. Okay. So I'll start. Mhm. That's fine. I'll start from scratch. Do pass me the link. Okay. Yeah, sure. So I'm starting from the beginning again then. Okay. Hello, everyone. So for today's topic, we have machine learning pipelining with Spark and TensorFlow. So I'm Rajat Bachchaji. If somebody is joining right now, I'm software engineer at Tapito, and yeah, otherwise I freelance and do part-time research. So that's where my experience from Spark and TensorFlow comes from. Also, I was employed at a different company which used Spark heavily. Disclaimer: prepared slides that I might not be reading from, ironically, which I am reading right now. And the session is about the boring part of the machine learning. So, like everyone else, I also don't enjoy the part where I have to deal with getting the data in the right format to be put into the model. So it's always the boring part of the entire pipeline, and it's also the majority of the work that you will be doing almost every time, no matter what change, because the changes to model are always quick. It's always the data that you have to work towards to actually make sure that it is in the right format and shapes. There might be few better optimization methods out there. These are like few general tips that you can always use, but otherwise there will always be more other hyper optimization tricks which you can use for specific use cases. Codes and other stuff are my personal opinion, so yeah, take it with a grain of salt. So what will we talk about? Why data pipelining, or like why put efforts behind into data pipeline. Next is Python patterns. So when we are processing our data using Python, what are the kind of patterns that we can and we should follow? So one is generators, the other one is NumPy vectorized operations. Then we'll talk about Spark. We'll directly jump into the code and look at like to actually work with Spark. We will understand what distributed computing is, and we'll see whether Spark can act as a good replacement for pandas. So we'll discuss about why should you and why not should you not use this. Okay. Next is optimizing GPU ML workload with TensorFlow. So TensorFlow actually provides its own class implementation called TF record, which allows you to efficiently load data and also push into quickly as possible. So basically, it's a binary serialized. It uses binary serialization and deserialization to make this happen. It's also recommended to use TF record if you're using TPU, the sensor processing unit, plus with Google buckets. So that's like the epitome of performance. Like you cannot go faster than that. So if you're having a pipeline created like that, you're set. Okay. So why this talk anyway? So just to begin with, there is no free lunch. So what does this mean? That just because you want to like push more money into your system and like try to get better processes, that won't work out because vertical scaling is long dead. So when I say vertical scaling, I mean to say that over the years, if you observe the history of computing, that processing speed has increased, but it has plateaued just about, I think, about 2007 or 8 maybe, because after that you might see that like currently the highest processor speed out there in the market might be just about, I think, just short from 5 gigahertz, or just maybe around somewhere there. You're not able to go beyond that simply because of the that the silicon plate used for like creating a processor, the amount of transistors that are dumped into that small area generates and so much heat that it's not possible, physically feasible to actually control that anymore. And also there's a problem with quantum interference happening at that level. So that's a different topic. The thing is, it's not possible anymore. So long live distributed computing. That is, we bring multiple machines, their multiple machines have multiple processors, and we utilize all of it together. So But the thing is that just because we have multiple processors doesn't mean that we will be able to use it efficiently. We need something that allows us to use it efficiently. So back in the like old days, even in current days actually, C++ has, I think, called this OpenMP. Or if you want to go through the Java, it also has bindings for the same. Or if you want to go a bit modern, that is 2015 modern, then Apache Spark is the way forward. Uh, Back in 2004, you might have heard about this particular term. It's called Hadoop, right? So 2004 was the first time that Google released their own internal paper, like how they handle data in large scale, which were primarily two papers, that was MapReduce and Hadoop, MapReduce and Google File System. So Google File System was the base of Hadoop file system, or like Hadoop file system software, and Google's MapReduce was obviously Hadoop's MapReduce pattern. So Spark actually builds upon that MapReduce pattern. So the earlier Java way of doing MapReduce was very cumbersome. Like you won't like it at all. You will have to implement your own classes and then get them registered, and then you'll have to launch it through I think Hadoop Submit or something like that. It was very cumbersome. But Spark makes it far more easier. The entire syntax is worked on Scala, which is a functional language and a very nice one at it. So yeah, so basically Spark makes distributed computing a pleasant thing to work with. Data pipelining is, so yeah, so coming back to why data pipelining is important, as I've already said, that using clusters computing efficiently. So so if you have to use it efficiently, you need a good tool for that. Spark is the de facto tool for it. What other thing that focusing on data pipelining helps us with is it's do away with potential IO blockades. When I say do away with potential IO blockades, what do I mean? So here's this one example. So the other day, my friend actually, he's a final year student, and he's working with some machine learning model, and he said that the cluster was not like the GPU utilization was stuck around 30%. So the cluster was not utilizing his data or neither the GPU properly. So the big question is why. The first thing that comes to my mind in such cases is that the GPU is getting IO blocked. So what does it mean by IO blocked? The thing is that the rate at which the data is read from the disk to the memory, and then memory to the vGPU, that is the VRAM of the GPU, is very slow. And since that's slow, because of that, the GPU is not getting enough data to process rapidly. So there's that. And the next thing is that large part of enterprise ML is about this. So yeah, if you are like thinking of going into the ML field, like you want to be a machine learning engineer, you should know about the various technologies that are involved in like processing data and creating efficient data pipelines, because a large part of the effort goes into that. The model comes at the very end, where you like start tweaking with the features and see like what you can do with it. What kind of parameters would you require for that particular model? It's you might have also heard this term. It's also called ETL. So this data pipelining or data engineering, this is called ETL. This is what you call the extract, transform, load workload. Okay, so we now understand what data pipelining is, hopefully. So who does this? Yeah. So this is okay. So we know that data pipelining is done by data engineers. So I'm just like highlighting so that nobody has any issues with it ever. Like as in, like if you ever hear this term like data engineer, you might be like, oh, what does a data engineer do? What kind of engineering there has to be done with data, right? Moving forward. So let's move on to the code, but before that, so Python generators. So from here on, let's start the hands-on. So I have the CSV. And I'll try and read this. So actually I was thinking of doing it another way, but actually Jupyter helped me to show it directly that what's the problem with something like this. So I'm actually waiting on the link for the stream, because I wanted to ask you things, but never mind. So I'll just go along with it. Is what do you think that will happen if we actually try to read the data like this? So currently, tweets.csv I think is about 3 MB. So what's like the estimate that might happen? Well, what I'm thinking might happen is it will try to read the entire data at once. So when I try to do that, hopefully it will run. Okay. When I try to do that, obviously Jupyter complains about that it cannot like print the entire file here. It's not possible. It's too big of a buffer. So what's the next thing? What's the next best thing that you should do? What's the next best thing you should actually do? The next best thing is create generators. So what are generators actually? So you might have heard of the concept called coroutines, and even if not, coroutines are like a very, what do you say, very innovative, very succinct and cool concept. So you have like one function, function one, and you have like function two. So the idea is that function two will be referring to function one, and when we call function 2, right, what will happen is that during processing the code will be jumping from function 2 to function 1 to do some job that is not complete as of yet in function 1. So in this case you can see that I have this red yeah, ret gen, and when we try to like use this, the generator, yeah, so now this time we don't have a error like this. I'm not sure why this is. Oh, it's actually from PySpark. Okay, so let me explain what's happening. So the earlier example, you can see that file.read, it was trying to read the entire data into the memory. Now we are no more doing that. So what we're doing is that we're taking each line from the file and we are yielding it. So yield is a statement that actually creates like turns any function, any generic function into a generator. And then you can actually get all the data from the generator using next, or you can also try this. Something breaks. I'll try to fix it because I'm just live coding. Yeah. Hopefully it will work. Yeah, okay. So you can also do this. So basically it will consume the file completely, but here's the best thing. The best thing is that it won't consume the entire file into the memory directly. It will read it line by line, and well, it will keep your memory light. So why I emphasized on generators is that you should be using this when you're creating your pipeline. Okay, so whenever, so it's a very beginner's mistake, and like I'd say that even I have done when I started out, is that we end loading the entire data set into memory at times. So pandas.csv, so people have a tendency of using pandas, right? So pandas.csv is one of those examples where you should not do that. That if you have a massive CSV, like I'm talking about something about 500 or 600 MB of CSV, do not try to load it directly if you do not have enough RAM, because that is text file. Text file when loaded into the memory might expand based on what kind of extra metadata is getting added to it. Okay, so like just for an example, if you're like going to the bit of fundamentals of computer science, is like if I have like one char, that's what, 8 bits. Yeah, sorry, my bad. One char is 8 bits, and that one char is actually a digit, which is 0, right? But the problem is when it's loaded, and if the if pandas is able to like infer the data type well, then it will convert it to an integer. Now we all know the size of an integer. Actually it depends upon the language, but let's just assume it's 4 bytes. Okay, so 4 bytes is basically 32 bits. So you can see that suddenly it's 8 times data for the same text file that we are trying to read, right? So do not do something like that. Do not try to like load your data directly into the memory. Think about it, and like put good thought that how you can efficiently do it. So one of the tips that you can do so efficiently is definitely using this generators. So you don't read the file completely, you read it by batch. You can also do is that you can take your CSV and split it apart so that it's in smaller chunks, so that it's much more easier for you to analyze and then leverage some other computing framework, just like we'll be discussing about Spark, to actually analyze your entire CSV together. That's your 600 MB file together. Okay, there's generators. That's Sean meme saying one simply does not make it good. Okay, so yeah, I'm not sure that from where this meme is, but yeah. When you replace for loop with the vectorized numpy function. So let me try something. Numpy as MP. Just a fair warning that things might break here. Okay. So np dot it should be rand. Sorry. Rand. Okay. So let's create a 5 by 5 matrix. Let's try to visualize what's happening here. So I'm going to show what vectorized computation is all about. So now, for example, we have this matrix, right? A 5 by 5 matrix. And this is your data input, right? But before you do this, you actually want to do a thresholding operation on it. So what is thresholding? Thresholding means when suppose AI is like greater than some threshold, then you will actually consider it as 255. Okay, and if it is lesser than threshold, then it will be 0. This is generally done when we are trying to mask images, and especially binary mask, or we are trying to create a binary mask. Then in such cases this is really helpful. So the question is, how do you do that? So here's the thing. If you try to loop, because the moment anyone would see this AI, they might be thinking that, okay, so let's loop through the data, because it looks like a two-dimensional, like it's a two-dimensional data, right? So someone might like start writing a two-dimensional for loop, right? So it will be 2 for loops going through each of the entries and then replacing it, right? So yeah, we can do that, but then again, the problem is that it's slow. So here's the thing. So here's the funda here, is that Python loops are slow. Like if you're going for scientific computation, Python loops are de facto slow. So don't ever use Python loops. Like if you're going for some like traditional software, then that's a different case. But for any kind of scientific computing, don't rely on Python loops. Rather, what you can do is, hopefully this will work, a dot 0.5. I think that worked. So when we did a greater than 0.5, it actually gives us a Boolean matrix. So this Boolean matrix tells us that where exactly it is greater than 0.5. So you can see it's 0.13 here, so it's false, it's true. Now here's the thing. So why do this is because when we are doing it through NumPy, NumPy is actually AVX compiled. NumPy also uses your CPU threads. So I think currently we have 2 running threads here. Wait, let me check that. Yeah, Collab actually gives us 2 threads. So it will basically use all of your threads and also add Intel's AVX compilation advantage along with it to make sure that your processing is as fast as possible on your CPU, because NumPy is running on CPU. It's not a GPU computation framework. Okay, so there are GPU alternatives to it. So let me just write it down. GPU alternative to alternative to NumPy is JAX. There's JAX, and I think there's another called Number. I don't remember, but JAX is one which you should look into. Okay, so JAX is actually from Google, so they use it for internal research, right? So let's actually complete this code, that how we can actually do it. So remember the thresholding operation. So we'll try something this time. Okay, let's try it. Let's see whether it works. Turns out it works. As you can see, wherever the value was above 0.5, that's now replaced by 5. So this is one of the most primary operations that we do in thresholding. That is, we look into some like estimated threshold and then we replace the values according to it. But do not use loops. Rely on NumPy's index methods and then use that to assign values to it. So this is an example of vectorized operations. So when you're using NumPy to process your data, try to rely on vectorized operations wherever possible. Okay? So that's a piece of advice that you should always like keep in head. If you're finding yourself to use loop, Google around, chances are you will find some interpretation. Okay, but again, to reiterate, avoid loops. So yeah, straight to Spark then. Actually, so let me just put up a question here. Oops, just wait. Okay, so I have not seen the answer yet. So as in like, I don't know what the value of A is. I have no idea. So what I want is people to actually come up with an answer for the thresholding. So what I want to do is now is actually, so here I was saying that we have only like assigned it to 5. So what I want to do is, if A is less than something, so any point ij is less than something, like less than maybe 5, less than 5, okay, less than 5, then we go like allocated to 0, and if it is greater than 5, allocated to 1000. Oh, sorry, 100. So that's a question for you. So do try this. So this is actually for everyone. Okay, now on to Spark, the exciting part, because we all know about NumPy. So chances are a lot of you people may not be introduced to Spark, because again, Spark is not something that's like much popular in terms of like, you don't find any use case to actually use it. Even I had to like revise myself yesterday night just to make sure that I get that code right, because again, it's not something that you will use all the time. So where does Spark actually jumps into? Spark comes into the context when the data is large. We're talking about large data in terms of kind of data that OpenAI works with. So I think OpenAI got their entire, I think they scrapped maybe hundreds of gigabytes of data for their GPT-3 model from internet. So you need Spark for processing that kind of data, that amount of data. So that's only when Spark comes into context, because you cannot process like 300 gigabytes or 1 terabyte of data in one single CPU. Like, you're just wasting your own time and also the resources that you might have. So basically, you have an employer who can throw money to actually get more computers, but if you don't use Spark, you cannot utilize those other computers, right? So yeah, use Spark. So Spark's context, like Spark comes into the context when the data is huge. So this is one cheat sheet you can actually take a look into. So if you're new to Spark, PySpark will make it much more easier. Okay. There's another book from O'Reilly, The Definitive Guide to Spark. You can always look into that also. It's very cool. Okay, so let's start our processing now. So again, back to the same thing. We'll be using tweets.csv, which is I actually got from Kaggle. So you can actually look into where I got it from. This is actually a US Airlines sentiment analysis challenge, I think. So I got the data from here. So it's actually dummy data, so nothing very serious to look into. Okay, so let's start. So the first thing that we do is, oh my god, what happened? Okay, okay, got it. So I think I might have to restart the runtime. This is what happens when you are live coding. So while the runtime restarts, just see if there's a question. Did the runtime restart? Oh, great. Okay, so I think we already have the necessary stuff here. Chances, I guess. Okay, let's do this. By the way, this notebook, I think Subrat already has this, so he will share it to you guys. Like whoever is attending, he can actually share this in the chat itself. So you can actually directly look into it. Yeah. So this is one really like nice, succinct way of having Spark deployed on Collab. Generally, it's not like Collab doesn't give Spark directly, so you can have Spark on your Collab. And for anyone who doesn't know where I'm working, this is Collab, called Google Collab. Google Collab. So basically, you can run, you get free GPU time. I think about 12 hours to run your machine learning workloads. It gives you a Jupyter notebook like this, where you can do stuff and experiments. Hopefully this time it should work. Okay. Yep, this one's working. Okay. And hopefully this should not break. Okay, did not break. Thank you. One of the problem with live coding is that it's kind of embarrassing when it breaks. Okay, so let's take a look into the data that we'll be trying to transform, and while transforming we'll also discuss that why are we doing this using this completely new framework that many people who are actually introduced with pandas may find it cumbersome to work with. Why even go this route? Here's the thing. Let's look at the data. See that there are nulls, and like this data needs some sort of cleaning. So we'll go through that. Okay. First, so here's a nice function that is describe and show. So before that, let me show what I've done. So I have asked Spark to get to read a format. Read a file which will be of CSV format. I've said that the first line will be of header. That's true. And I've also said that, okay, you can directly infer the schema from that. And then finally load the file. So those of you who might be introduced with pandas, so pandas has this concept of data frame, right? We generally allocate our variable or whatever data we are reading, that is pandas from CSV, I think it's. So you directly allocate that into data frame or as a TF variable into data frame. So Spark does exactly that. So Spark has the similar concept of data frames. This did not exist beforehand. I think back in 2015 it was all RDD. So Spark uses this concept of what we call as a resilient distributed data set. Resilient distributed data set. Yeah. So that's what the RDD stands for. So what RDD does is basically it abstracts away all the operations that are to be done on the data, and also makes the operations uh, as what we call as transactional rollback, like compatible with transaction rollbacks. So what I mean by transaction rollbacks is that, for example, if you do an operation with an RDD, so an RDD, remember, represents a data set. A data set in this case is this CSV data set. Well, it represents a CSV data, any kind of data set. And if you do some operation with that RDD, and suppose in your cluster you have deployed the job, and if something fails in the between, let's suppose your cluster is on fire for some reason, I don't know, and if something like that happens, and even if one single node survives, that Spark will make sure that the RDDs roll back all its operation and start from a point where the data is consistent. So how it does that is that each operation on a RDD, remember RDD is just an abstraction over the data or data set that we're using. Operation on RDDs is actually a directed acyclic graph. This is just right. That okay, it's a directed acyclic graph. So since it's a directed acyclic graph, it knows how to roll back, right? So those who have worked with TensorFlow might know about this concept. Is that TensorFlow also leverages DAGs. Any kind of machine learning model turns out to be a DAG. Kind of a recurrent network. Recurrent networks are confusing. Okay, so I think this part is obvious. So we get the first row. So describe is one good function. I'm not sure whether pandas has it or not. It might have. So describe actually gives you batch statistics. So statistics as in, like, it gives you the count. It'll give you the mean, the standard deviation, min and max. So you can see that it's a completely off and wrong data here we're getting, right? We also have print schema, which gives you an information of what kind of data are we dealing with, the headers. So it tries to actually infer from it directly, but you can see that it's most of it is just string. Some of it is integer, but most of it is just string. Why? Because like it's not able to infer the data type properly because it needs cleaning, right? Okay, so let's look at the total count of data. That's okay. So let's start with cleaning the data. So we will actually look into 3 columns, and we're only interested in these 3. So one is airline sentiment. So in the data, this is airline sentiment. So this will act as our class target, maybe. So neutral, positive, negative. These are our class targets. There's another called airline sentiment confidence. This will act as one of our features. And there's another one, yeah, retweet count. So basically it says how many times retweeted. So there's that. Okay, so let's start cleaning it. Okay. I mean, at this point you're basically like doing a lot of plumbing job, but plumbing job with distributed computing. There's the thing. So what we are doing here is that we're just picking up like positive, negative, and neutral and turning them into proper format. So as you can see now, if I do a distinct, it only gives me these 3. There's no more any null. So I would encourage you guys to actually go through the code once so that you understand what's happening. Otherwise I'll just actually run through them. So yeah, we rename the column. So here I'll stop here and show you something. So you might see that I'm actually doing a lot of function called show. So I've been talking about this, like that Spark uses distributed computing. Spark comes in context when your data is really big. But here's the thing. if your data is big, if you try to pull something like a dot show, like dot show function on it, it will try to like gather a lot of data from your entire distributed cluster and try to bring it to you. So what we do is that we just like write show 20 and it limits the amount of data. So Spark has like two primary kind of operations. One is transformations. So you might see all these like df with column and then like drop na, which actually drops the null values, filter. All these are actually transformations. So here's the big aha moment is that right now Spark is doing nothing. Like I have given all these commands, Spark is simply creating a graph internally. It has done none of the processing as of yet. So you might wonder that, wait, if it hasn't done anything, how am I getting this? Why? Because I'm actually calling this distinct, and distinct is something we call as actions. And actions are aggregators. Well, aggregators would be a wrong terms, but aggregates the partitions. Partitions as in the data partitions. Okay. So when I say it aggregates the data partitions, I mean to say that it starts to do all the operation and try to bring it to the user, whichever like master controller the user is using, like wherever the user demands it, it tries to bring all the data there after processing it. So an operation like distinct, which is called action, is what will trigger the entire Spark workflow. So till now, all this happened just like bunch of transformation or like just creating new classes, which will register what operation needs to be done. Okay. Now, why this? And this concept has a name. It's called lazy evaluation. It's very popular in functional programming. So as I said, Scala is Spark is also. So yeah, we do a distinct, and we know it's an action. That's why we're able to see all the data. But when it is show 20, yeah, sure. Let's see. Okay, not sure. Is it better now? Okay, sure. Thank you. Okay, so I'll just emphasize on the sample function. So since we know that distinct will actually aggregate everything, like it will, because those of you who might know about SQL and have used the distinct operator, this is exactly that. You're actually getting the distinct entries for clear aligned sentiment column. So in that case, in such cases, it's best you use this function called sample. So what will sample do? It will actually randomly sample from your data set some, and in this case I have written 0%. That means it will sample 30% of the rows, and then we do a show on it. Because why do this? So that like we do not need to get the entire data set. Because remember this, when you're actually writing Spark, again, just to reiterate, you're not working with small data set. You're not working with small data set. We are working with big data sets. So just to like say big data, right? So yeah. So that's why we do this sample, so that to limit our results. Remember this, whenever, again, I'll just reiterate again, actions only do when you require the final result. Or you want to just see. If you want to just see, just do a sample. Okay, so we have done our transformations, and hopefully just to reiterate this. So we'll try to clean this also. Filter df augment reference count. Okay. So at this point, I would like to answer one thing: is that why do Spark, right? So you already have a good idea, like, okay, Spark is when you have large data, when you have a distributed cluster, but what benefit do I get against smaller data, and why should I like abandon pandas at all? The answer is you need not abandon pandas, right? Like, it's fine if you're comfortable with pandas. If you want to use pandas on your local machine and your data is small, then it's completely fine that you can do that. But if you're writing for something that has to be deployed, I'd highly recommend to actually do it using Spark. Why? Because what right now, whatever code I'm writing, right, this can be directly put into production. Why? Because all you have to do is just submit this script and Spark will pick it up as a job and Spark will keep running it. So there's something called Spark streaming. So again, something for you guys to read is what Spark streaming does. So let me give a heads up on that. Spark streaming will enable you to actually drop in CSVs. So you can just drop CSVs into your file system and Spark will keep picking them up. So basically this will be real-time processing. All these processes that you have, like all these transformation that you have declared, Spark will pick those up and like pick the files and then apply those transformations on it, happening in real time. So that's the thing, that's the advantage that you get with Spark, is that you're not just writing experimental code, you're writing code that can directly be deployed. So again, less work obviously if you're into a production setting. Otherwise, pandas does the job fine as well. Pandas also have some extra visualization, so there's that part. But Spark also, again, as I've said, Spark gives you good streaming capability. So if there are trade-offs, it's up to you that when you should use what. Okay, let me just make sure to run this again. Otherwise, now it's just a bunch of operations to actually clean the data. So just show it from the table of content itself. So we are actually primarily interested in three columns. One is airline sentiment, the other one is airline sentiment confidence, and the last one is retweet counts. Right. Let me just quickly reach to the end. So here we should get our final data. So here's our final airline sentiments. We have neutral, negative, positive, and airline sentiment confidence, right? And we have retweet count. Okay, so yeah, the three columns that we're interested in, we have finally processed them out. And the best part of this Spark processing is that none of the processing actually have happened as of yet. That is, for example, instead, if this tweet.csv, it's currently just 3 MB. If that would have been about 3 gigabytes, still this process would have been this quick. Why? Because none of the processing actually happened. It's just that this sample, like we have described, right, that taking a small part of the entire data set and just want to visualize it, whether the operation has been, and Spark will make sure of that. It won't transform your entire data. It will just take a sample of it and then do the job. So let's allocate it from there. Okay, so from here onwards, I'll just try to get the classes. What I'm now trying to do is transform this negative, positive, neutral into its index values. Okay, so let's visualize it at the end. Sure. And hopefully it will give the right output. Okay, so we have what label. Okay, so we have labels now. We have converted this airline sentiment into labels. We can also do is that we can apply a sample operation here. 0.5. Okay, 1. And okay, this is strange. Never mind. So it's actually getting randomly flushed. So yeah, it's all 1. Okay, so I think at this point I'm done with the Spark part. Is that I hope people who are watching right now have a good clue of what Spark actually does. Spark primarily fits into the data pipeline where you want to process your data and do some computation with it. So Spark also has a new GPU version, so which actually supports GPU workloads also. Not sure whether it supports neural network as of yet or not. But yeah, and Spark also has these other components, that is the MLlib and then graphics. All these responsible for like graphics is responsible for graph specific computation. MLlib is responsible for machine learning workload. So I think currently it has logistic regression, then decision trees, random forest. These are already implemented, so you can directly push your data in. So at this point, whatever data you have, from this point onward, you can like directly push your data into MLlib, or you can also process it, dump it into like, or like you can directly dump it into a GCS bucket, that is Google Cloud Platforms bucket, and then process that into a TPU or a GPU, whichever you want, right? So here's your data pipelining and efficient data pipeline to say. Let's now talk about TF records. So okay, so I think this link can be shared. I want everyone to actually take a view, look into this, rather this one actually. Uh, I'm sending one link, if possible, to provide it to the viewers if they're interested.
Okay, sure. I'll just
Yeah.
put that on the description. Yeah.
Yeah. So what's that link about? So let me actually open it on my end itself, so that those who do not have a laptop can view it. So better performance. So I'm hoping like most of you know about TensorFlow, might have heard of it. Even if you're not a machine learning aficionado, that's completely fine. TensorFlow is Google's offering for neural network processing. It originally started as a like a numerical computation framework, but again, for their internal workloads, they turned it into a neural network framework. That is, it's much more easier to write neural networks here. It also supports automatic gradients. But now in current date, TensorFlow also gives an API for how to load data in it. So when I say how to load data in it, I mean say that we have the data ready here, right? So we can try and like create an iterator out of it, and then iterate and push it into the TensorFlow model to get it training. But TensorFlow says that we can do it better. We recommend a different way of doing it, and that's through the TensorFlow Data API or the dataset API. So let's look into it. So I'll just show you the implementation, that how you can actually do something like this, and then we'll maybe, yeah, we can talk about like how it helps. So let's get it. Mhm. Okay, so I got the head 1000. So this means that current day I have actually taken a sample, small sample of 1000 data sets. Yeah, 1000 samples. So here's the part: is I need to first define what kind of data I'll be dealing with. So before that, I actually write this, like these are apart from the directly from the documentation, and these are the two most important part: serialize example and read TF records. So what is about serialized examples, and what do we mean by serialization? So the idea is that when you are pushing data to your GPU, right? Instead of going from the disk to the GPU in a format where you have to like load into memory, process it where the CPU kicks in, and then send it to the VRAM of the GPU, we can actually pre-process it and then save it as TF records, which are basically binary serialized version of the data, right? So when I say binary serialized data, I mean it's basically binary data. And we, when we are again deserializing it, we already have done all the pre-processing. We have already made sure that the data is in correct format, and we deserialize the data, and then we directly push into the VRAM of the GPU. This enhances the speed of the travel time of the data from the disk to the VRAM, Why? Because there is less CPU work involved here anymore. Okay, so and also there are few other advantages that I'll be coming in a moment. So let me just execute this and hopefully it doesn't give me error. Chances are it might. Okay, you can check this part of the code later. Nice, that worked. Okay, so dataset.tf record, that worked. Okay, okay, at this point let me just iterate on what I've done. Is that I have actually created a TF record writer, and then have written the data from the samples. So if you remember, I have taken just about 1,000 samples and then turned them into a serialized version of it. That is dataset.tf records. And after this, what we'll do is that we will actually load this data. So at this point, we are in the Wild West because I have not finished this code. I'm not sure whether it will even load or not. So yeah, Wild West. File names. Okay. Okay. It was able to load. Makes sense. But the shape has been wrong. Kind of feel that the shape, I think I got it wrong. Okay, so let me actually go through this code because this code actually is the important part. We can get it executing later. So what we're doing is that we record dataset from the existing TF records file that we have created. Now this is where the optimization comes from. Is that you could have done this by yourself also. Like you could have actually created a Python generator, like just the way that I have shown in the very beginning, and then simply put it into the model. But here where the efficiency comes in. First thing is that ignore order. So this is actually recommended from the Better Performance Guide. So you can directly go into there and pick up all these performance advices. So ignore order. Ignore order is all about it. TensorFlow will not care at which order is it reading the data. So suppose this data TF record is not located here. It is located in the cloud, okay, in the Google buckets. Then what happens? It might happen that one server is delaying the read. The other server has already prepared the data. So what we do is that we say ignore the order of the data because it doesn't really matter, right? We can want our machine learning model is not like specifically do care about the order of the data at all. Next is prefetch. So what's prefetch? So here is one advice is that always use prefetch so that you can try to utilize your memory as much as possible. So Linux has this philosophy is that free memory is just wasted memory. So in our case also, let's use this philosophy is that let's not waste memory. So all this time I've been saying that do not like overflow your memory, do not overflow your memory. But again, do not underflow it also. If you have filled up your memory and are like dynamically filling it up and then evicting stuff from it, then you are efficiently using it. And that is something TensorFlow Dataset API takes care of. Prefetch makes sure that your data is loaded even before the GPU is done processing it. So it is basically pipelining it. So pipelining is a concept. Those of you who have studied computer architecture, or even if not, I'll just go to it directly. Go to it in a moment. The next is dataset.map, where we actually say how to deserialize it. So read TF record is the deserialization of it. Okay. Yeah, deserialization of it, and then coming back. After that, finally we this one, and this particular parameter is very important. Again, one of the optimization is number of parallel calls. So when we say number of parallel calls, at this moment we are saying that use multiple threads to actually bring the data in. So we have looked into a few optimization, that is prefetching the data, using multiple threads to load the data, and then finally we just do a batch, and then we shuffle the data and provide it, right? So at this point, not sure whether data set, mm, not really sure how will it behave. So chances are it might error out because I haven't tested the code as yet. As number. Okay, so let's see. Chances are it might error out. Strange. Okay, this worked. Okay, so you can see that we loaded the data and we are able to load it successfully. Yeah, yes, we're able to load it successfully. So you can see that our original data looks somewhat like this. Yep, airline confidence, retweet count, and then we have labels. So I have also one hot encoded the labels while deserializing it. So you might wonder that why, because people what they do is that generally they create this one hot encoding directly into the pandas CSV and then actually load out from it. I would highly not recommend it when using Spark, because again, coming back to the same point, Spark relies on large data sets. So if your data is large and if you try to one hot encode it and you have way too many classes, then you will just end up adding redundant data that need not be there. So what we do is that we just simply create the one hot encoding when we are deserializing it. Simple as that. So yeah, and now at this point, whatever data we have, this can be pushed into a machine learning model. So yeah, that's it. So this is from my end, like how you can optimize and like make sure your data processing is efficient. You can also use this TF record idea for processing images also. Spark can be used for processing images, but it's a little bit cumbersome because then you have to ensure that your entire cluster has the specific libraries in their current context. But otherwise, Spark is well capable of that, and you can leverage Spark for distributed processing of your images also. So yeah, I think I'm done on my end, and all questions are welcome.
Okay. So we'd like to take some questions here. So anyone who have doubts and regarding this and any queries, you can just put it on the chat section on the yeah, below. Yeah. So we will be waiting for some time here.
Let me just add one question also.
Yeah, sure.
So I would highly encourage anyone out there to actually try it.
One more thing, the questions that just raised, including that, we will actually form a Google form out of it and just put it on the description. So just go ahead and just write those answers, and the top three will actually get certificates for that as a winners. And further, we will also share the link for the badges, and you can also collect it. I'll just share in a minute. So there is no
Yeah. So
questions
let
as
me
of
just
now.
put it out
Yeah.
today. So the first question, this first question, you will actually have to give the code that how you can do this, right? If you like whatever code you give, I'll just take them out. If that's fine, that's yeah. And the next question actually be uh, so we have already processed the data, right? So try to get count of class 1, 2, and 3, which is positive, negative, and neutral. From the above dataset, you can try and get the count of these classes and report the numbers. So that's your question from.
Sure. We'll put it that all this thing in a Google form and just put the link on the description. So yeah, I think we will wait for few, I think 1 or 2 days, and then I will get back with the winners for that. And as for I think there is no questions as of now, Ajanta. So basically, you will just move ahead. And for the badges, Ajanta, can you just stop presenting this? I can present my screen for a second.
Yes. So are there any questions coming in?
There is no such questions as of now. Yeah. But again, I think go through the code. So basically, you will have doubts regarding that. You can actually connect with Janta in the actually I have given the link for as well. I'll just put the link of the LinkedIn profile of Janta so you can connect with him there as well. So yeah,
Sure.
sure, yeah.
So are we like waiting for a few minutes or should I drop off?
Yeah, actually, no, you can actually wait. I just stop the presenting. Actually, I'd just like to share the code for the badges actually.
Oh yeah, got it.
Yeah,
Let me.
sure. Is my screen presenting right now? Can you confirm, Diksha?
Yes, it is.
Diksha is okay. Great. I'll just go to this. I'll just show. This actually can go to this link bit.ly / explore DSC, and you will actually get this site right here, and you can earn your patches. Just click on this link, and yeah, and just put the code here. I'll just give you the code right now. For the ML section, this is your code. This capital M, then small l, then capital T, small l, then K, then just give a hyphen and just one. You can just go ahead and just put this link on there and you just get download the badge from there as well. So this will be the, I think this is visible. So I think this is the code for the badges, and yeah, I think, and for the further part, actually, the link for the Google form will be given on the description, so you can go ahead and just get your answers there. And after that, we will actually declare the winners after some time. So that will be on our Instagram handles as well. So thanks to everybody for attending this session. And yeah, that should be it. Thank you so much. Yeah, go ahead and end this one. Yeah.